This is a brief introduction to significant figures and the rules that guide us as we look at measurements, and then also, given a measurement, how you would figure out its uncertainty. So supporting topics would be measurements and the metric system. The question that we are faced with when given a measurement is who counts as a significant figure. So all numbers that are not zero count as significant figures. The issue becomes to decide what to do with those zeros. So zeros in the middle of a number always count as significant figures. So if I had 109, this zero is in the middle of the number and it would always count as a significant figure. And the 1 and the 9 would count because they're not zero. So this would have three significant figures. Zeros at the start of the number never count as significant figures. These are often referred to as leading zeros. And this would be something like 0.003. We know the 3 counts as a significant figure because it's not zero. But all of these zeros would not count because they're at the start of the number. So this number would only have one significant figure, or sig fig. Zeros at the end of the number count sometimes. They count if there's a decimal point that's explicitly present, and they don't count if there isn't a decimal point. So if I have 300, and there's no decimal point shown there, then this 3 counts as a significant figure, but these zeros do not. And so there would only be one significant figure in 300. On the other hand, if I had 300 point, then this 3 would count, and these 2 zeros would count because there's a decimal point specifically shown in the number. So let's look at a couple of examples. Oh my goodness, I just did 300. So let's do a different one. Let's say we have 5,050. So thinking about our rules, we know that all the numbers that are not zero are always going to count. The zeros that are inside the number, or in between any non-zeros, are always going to count. And then we have to check out the zero at the end of the number. We know that only counts if there's a decimal point shown. There's no decimal point shown here, so this number has 3 sig figs, or 3 significant figures. 20,390, excuse me, the 2 counts, the 3 counts, and the 9 counts. This 0 in the middle of the number counts, but this 0 at the end does not, because there's no decimal point attached to that number. So it's different than your math class, where you could imagine decimal points or add decimal points if you needed them. We don't do that. And that has something to do with uncertainty, which we'll talk about next. So this number has 4 significant figures. 0.01, the 1 counts, but these 2 zeros at the beginning of the number, even though there's a decimal point, both of those zeros are at the beginning of the number, so neither of them counts as a significant figure. So there is only one sig fig here. 6.34 times 10 to the 5th, we actually don't care about the 10 to the 5th because that's just telling us how many placeholders we have. So I ignore this value when I'm figuring out the significant figures of this number, and I just look at these numbers over here. And I have 3 numbers that are not zero, so this has 3 sig figs. Down here, another number written in scientific notation. I don't care about the 10 to the negative 8th. I do care about the 4 and the 3, and this time there is a decimal point specifically shown, so these 2 zeros count as well. So this has 4 sig figs. Where is the uncertainty in a measurement? Well, it's always found in the last significant figure. So if I was to look at these measurements, 0.030, I need to find my last significant figure. Well, we know these zeros at the beginning of the number don't count because they're leading zeros and they never count. That 3 does count. There's a decimal point shown in the number, so that 0 counts. So now I can see my last significant figure is in that decimal place. So the uncertainty would be 0.00, plop a 1 into the decimal point place where I find the uncertainty. So we'd say this has an uncertainty of plus or minus 0.001. 10,200 significant figure, significant figure, and significant figure. These guys are not significant figures. So here is my last significant figure. It's in the 100th decimal place, so I would say plus or minus 100 is my uncertainty, because I guessed in the last sig fig. 9.29 times 10 to the 5th I have to write out so that I know where my decimal place actually is here. And so I've transposed it out of scientific notation, and I see significant figure, significant figure, significant figure, not significant figure. So my last significant figure is located in that decimal place. That is the thousandth decimal place, so my uncertainty is plus or minus 1,000. Similar idea over here. I have to write it out, keeping the same number of significant figures. So I have this 0 here, so I keep that 0 when I write it out. And that 0 is also my last significant figure. So my uncertainty is 0.000, plop a 1 into the decimal place where my last significant figure is.